Hello everyone, welcome back to my channel. So today we are going to study rational numbers part 2. In rational numbers part 1, we have already understood what are rational numbers. So today let's see the properties of rational numbers. The properties which we are going to consider are the property of closure, the property of commutativity and the property of associativity. So these properties we will see for whole numbers, integers and rational numbers. So let's first see the property of closure. So for that we are considering whole numbers. Now the operation which we are considering is addition. So the property of closure states that if we are considering two whole numbers, then if you are adding it, then the result should also be equal to a whole number. Then we will say that the whole numbers are closed under addition. So here we are considering two numbers 0 and 2. Both are whole numbers. So adding these two numbers, we are getting it is as equal to 2, which is a whole number. Similarly, considering numbers 3 and 5. So by adding 3 and 5, we are getting it as equal to 8. So this is again a whole number. So here we can say that if A and B are two whole numbers, then A plus B is also a whole number. So the remarks which we can state are whole numbers are closed under addition. Okay. Now let's consider subtraction operation. So for subtraction operation, again we are considering certain whole numbers. 9 minus 2, that is equal to 7, which is a whole number. Considering 0 minus 2, so this is equal to minus 2. So this is not a whole number. It's a negative integer. Similarly, 3 minus 7, it's coming as equal to minus 4. Again, it's not a whole number. It's a negative integer. So now we can say that if two whole numbers A and B are there, then A minus B is not always equal to a whole number. As you can see from the three equations, the first equation is giving us a whole number, but the second equation and the third equation are not giving us whole numbers. So that's why we can say that if we subtract two whole numbers, then the result is not always equal to a whole number. So the remarks are whole numbers are not closed under subtraction operation. Now let's consider multiplication operation. So for that we are considering 5 and 4. So the product of 5 and 4 is 20, which is again a whole number. Consider 2 and 0. So the product of 2 and 0 is 0. Again it's a whole number. So we can consider any number, any whole number, and we will find out that the product of the two whole numbers is always equal to a whole number. So here now we can say that if A and B are two whole numbers, then A into B is always a whole number. So the remarks are whole numbers are closed under multiplication operation. Now let's consider division operation. So for division operation, again we are considering two whole numbers 5 and 3. So if you divide 5 and 3, means 5 divided by 3. So that is 5 by 3. This is not a whole number. What type of number is it? It's a rational number. So similarly, we can consider any two whole numbers, and if you divide those two whole numbers, then you will not always get a whole number. You will get a rational number or you will get an integer. Okay, but whole number is not possible always. So if A and B are two whole numbers, then A divided by B is not a whole number. So whole numbers are not closed under division. So for whole numbers, we have seen that whole numbers are closed under addition and multiplication, but whole numbers are not closed under subtraction and division. Now let's consider integers. For integers also, we will see the operations addition, subtraction, multiplication and division. So first let's consider addition operation. So again here we are considering two integers, minus 7 and 2. So minus 7 plus 2 is equal to minus 5. What is it? It's a negative integer. Okay. Similarly 3 plus 5, it's equal to 8. Again this is an integer. So we can say that if a and b are two integers, then a plus b is also an integer. So the remarks are integers are closed under addition. Next we will consider subtraction operation. So for subtraction operation, let's consider 9 and 2. So 9 minus 2 is equal to 7. So 7 is an integer, positive integer. Then 0 minus 2, it's equal to minus 2. Again it's a integer, negative integer. Minus 5, minus 8, it's equal to minus 13. Again it's an integer. So whatever integers we take, if we subtract one integer from other integer, we will always get an integer. So integers are closed under subtraction. Next we will consider multiplication operation. So for multiplication, again we are considering minus 5 and 4. So the product of minus 5 and 4 is minus 20. This is an integer. Similarly, minus 2 into minus 6, that is equal to 12. That is also also an integer. So if a and b are integers, then a into b is also an integer. So the remarks are integers are closed under multiplication operation. Now coming to division operation. So for division, we are considering 5 and 2. So 5 divided by 2. This is equal to 5 by 2. So this is not an integer. It's a rational number. Similarly, minus 8 divided by 3. That is also not an integer. That is also an rational number. So we can say that if we are taking two integers and dividing those two integers, we will not always get an integer. So the remarks are integers are not closed under division operation. So finally for integers, we can say that for integers, integers are closed under addition and multiplication, but integers are not closed under division. Yes, one more thing. Integers are also closed under subtraction for this closure operation. But for whole numbers are not closed under subtraction operation. Now moving on to rational numbers. So here first operation which we are considering are addition. So here minus 8 upon 3, this is one rational number, and 5 upon 6 is another rational number. So we are adding these two numbers. So if you add minus 8 upon 3 and 5 upon 6, how will you add? You have to take LCM. So 6 into 3, that is coming as 18. Okay. Now divide this 18 with 3. So what will you get? 6. 6 into 8 will be equal to minus 48. Okay. And then divide 18 with 6. So what are you getting? 3. So 3 into 5 is equal to 15. So minus 48 plus 15 upon 18. So that is coming as minus 33 divided by 18. So what type of number is this? It's a rational number. Okay. So we are adding two rational numbers and we are getting it as a rational number. Now consider another two set of rational numbers. So if you add these two rational numbers, then also you will get a rational number. So for rational numbers, we can say that if two rational numbers are there, and if we are adding those two numbers, then the result is also a rational number. So the remarks are rational numbers are closed under addition operation. Now let's consider subtraction operation. So let me remove this equations. Okay. So now for subtraction, again we are considering two uh, rational numbers minus 5 upon 7 and 8 upon 3. So we are subtracting these two numbers. Like we have added two rational numbers, similarly we can subtract two rational numbers also. So the LCM of these two numbers is 21. Okay, so first we will divide 21 with 7, so we are getting it as equal to 3. So 3 will be multiplied with 5, so minus 15 is coming. Then again we will divide this 21 with 3, and we are getting it as 7, and that 7 will be multiplied with 8. It's coming as equal to minus 56. So minus 15 minus 56 divided by 21, that is coming as equal to minus 71 upon 21. So this is also a rational number. Similarly, you can consider another set of rational numbers, 9 upon 2 minus minus 11 upon 5. So this also we are getting as equal to a rational number. So minus 67 by 10. So here we can say that if A and B are two rational numbers, then A minus B is also a rational number. So the remarks are rational numbers are closed under subtraction operation. Now coming to multiplication. So for multiplication, again we are considering two set of rational numbers. Here you can see minus 9 upon 4 into 3 upon 7. Okay, so when you multiply these two numbers, then you will get minus 27 by 28. You have to multiply the numerators and you have to multiply the denominators. So the product is minus 27 upon 28, which is a rational number. Similarly, 1 upon 4 into 8 upon 3 is coming as equal to 8 upon 12, which is again a rational number. So if we are considering two rational numbers, then the product of those two rational numbers is also equal to a rational number. So the remarks are rational numbers are closed under multiplication operation. Now let us consider division operation. So for division, I have considered the rational numbers 5 upon 2 and 1 upon 3. So 5 by 2 divided by 1 upon 3 is equal to 15 upon 2. How will you divide it? Let me show you. So for dividing, what we have to do, I am writing it over here as I don't have space. 5 by 2 divided by 1 upon 3 is equal to 5 by 2 into 3 upon 1. Okay, so that is equal to 15 upon 2. So like this we can do the division by using rational numbers. So this division is equal to multiplication, that is converted into multiplication by changing the number. Means this denominator will go into the numerator and the numerator will come to the denominator. So likewise you can multiply these two numbers and this product will give you the division of the number 5 by 2 and 1 by 3. So here similarly minus 6 upon 7 divided by 5 upon 8. That also we can write like this, minus 6 upon 7 divided by 5 upon 8 is equal to minus 6 upon 7 into 8 upon 5. So this is coming as equal to minus 48 upon 35. So again this is a rational number. But what about 5 by 2 divided by 0? What will you get? So this is not defined. Any rational number divided by 0 or any number divided by 0, that is not defined. Okay. So here we can say that excluding 0, if you do not consider 0, so excluding 0, if A and B are two rational numbers, then A divided by B is a rational number. So the remarks are excluding 0, all other rational numbers are closed under division operation. So finally for rational numbers, the closure operation goes like this. Rational numbers are closed under addition, subtraction and multiplication and also division. but for division excluding 0, all other numbers are closed. Okay, I hope all of you understood the property of closure. Okay, so in the next video we will see the property of commutativity. If you have any doubt, then please let me know in the comment section and I will try to solve your doubts. Thank you.